Hi guys, greetings from Bulgaria, I am Anton, and in today's video we are going to discuss SmartWait functionality for Selenium testing. Here is a quick overview of what we are going to discuss. First, of course, what is this feature, why you need to care, what problems does it solve, its pros and cons, and there will be tons of practical demos to show you the exact benefits of it and the small disadvantages in some cases. Of course, if you haven't subscribed to the channel, please do so, hit the ring bell so that you get notified when new videos are published. Each week there are tons of new material, really excellent videos, and also check the Lambda test blog because there are a lot of really helpful articles to help you become a really great engineer. So let's discuss now what are the smart weights. There is a really excellent book about it, transforming web automation with Lambda test smart weights. You will find the link below. As you know, as always, you will find other helpful videos and articles and related materials, and also you can clone and get access to the source code. So check out this article. In short, we'll cover everything from it, of course. We're going to discuss the smart weight. But first, in order to understand this feature, let me show you really quick our demo project and what problems this solves. If you watch some of my videos, you know that this is one of my favorite demo apps because it's using latest web technologies like asynchronous calls. Right now, when you open a web page, it doesn't immediately load everything, but in order to be reliable, as you can see, it's not loading every time the page, right? But instead it's using asynchronous calls to the server and it's refreshing just part of it. Many often when we have such a behavior, we need to explicitly, implicitly wait for the elements or use hard-coded pauses. You can watch some of my videos about using hard-coded pauses. This is not the best practice, of course, or explicit and implicit waits. We will cover shortly some of them here. But yeah, basically the problem with the hard-coded pauses, as you see, is that it's unpredictable when your test will fail. And we are not sure how long we need to wait. Sometimes the test will fail. Also, this will prolong the test because sometimes the page will load for example, 2 seconds. We'll wait for 10. This means that we'll wait additionally 8 more seconds. And this time will add up, right? Sometimes up to 30 seconds per test. But when you have thousands of tests, this is really huge difference. But the biggest problem here is not actually the prolonged test, but the unexpected behavior and false positives of the tests. So this is where this smart wait functionality comes into the play if you use the Lambda test cloud to execute your tests. Lambda test smart wait empowers you to perform a series of actionability checks on the web page elements before executing any actions. And this is, you don't need to write anything additionally like implicit or explicit ways. This is handled for you automatically, ensuring the flawless functionality of your scripts. This feature introduces the innovative smart wait algorithm, which intelligently waits until all necessary checks are successfully passed before proceeding with an action, for example, click or typing the text, for example, here. When you initiate an action on a web page element using Lambda test, this smart wait algorithm comes into the play, triggering this series of checks, examining the readiness. Like we'll discuss some limitations, like for example, it cannot wait automatically for all AJAX requests, but when we combine both approaches, really the code is much more readable and maintainable. However, if any of the checks fail to meet the specified time frame, the algorithm intelligently, as you will see, returns the relevant Selenium error message, enabling you to identify and address any issues swiftly. Now, this feature, it can significantly minimize the risk of these false positives or incorrect executions. You know that I'm against 100% ads, and I'm trying always to be objective. So probably if you use a reliable test automation framework already and it solves all of these problems, you don't need to migrate using the feature. And but you can notice also that we will cover that. You will see in the demos that you can notice that if we use in the best possible ways the explicit waits and wait for Ajax and the scripts, and we use design patterns, you can check the other videos. This approach will be a little bit faster than using SmartWait algorithm, because of course this comes with the price of doing all of those checks before the actions. This is normal, but it's just a small difference. However, for people that are just getting started or are not using this type of advanced test automation frameworks or have a lot of flaky tests due to these problems, this feature may be a game changer, and this is why we're going to cover it today. So, how to use it? First, of course, the first place to check it is to check the official documentation. If you use the capabilities generator, you will notice that this is still not there because this is a fresh new feature. However, you just need to provide here. You basically begin by specifying this maximum waiting time for your test scripts until an element becomes actionable, and customize this time limit according to your specific test requirements. You can experiment. Sometimes 10 seconds are not enough, maybe you need to increase it. Yeah, so then you execute the test suite. You don't need to change anything. You don't need explicit waits, nothing, implicit waits, nothing. Run your test suite as you normally would. Before executing each action on the web page, SmartWait automatically performs this actionability checks. So let's first create a demo, as I promised. We want to see how one test works without the SmartWait and without these implicit waits. So if we navigate to the home page, we're going to navigate to this particular website, and then we want to click on this Add to Cart button. In order to find it, maybe we can use maybe CSS. As you can see, we can use this data product ID 28. This is this button. Then we are going to click it, and as you can see, we have this spinner, so we need to wait, for example, for 5 seconds. And then we are going to click on this view card. To click on the view card, let's delete that. To click on the view card, let's examine it. We can find it by title or by class, it's up to you. Again, we can use CSS for that. Here it is, this is this link. Then we click it, and then we'll continue from there. So I created this particular class. Not class, but project. We have 3 test classes, 3 test files. One of them that we are going to write now will use these hard-coded pauses or thread slips. The other one will use implicit, explicit waits, and some JavaScript to wait for it. And then we're going to use basically the SmartWait feature. This is a standard Java setup. We use JUnit and Selenium. We use Maven for the dependencies. If you are not familiar with JUnit, check the videos below. There are whole video series about it on the Lambda Test channel. Or if you prefer TestNG, it doesn't matter. It can work with both. It can work actually in any language that Lambda Test supports. However, if you're not sure with these dependencies, we need JUnit to do the assertions and to run the tests. Also, we need the dependency about Selenium and WebDriver Manager. If you use Selenium after 4.11, you don't need the WebDriver Manager, since it incorporates the browser and the driver management in this version forward. But for backward compatibility, I put it here, and that's it. So for the hard-coded pauses, again, you can visit the capabilities generator of Lambda test. Even Lambda test is handling the drivers automatically for you, so you don't need the WebDriver Manager. You can copy all of those capabilities from the capabilities website. You have all of these unlimited variations and combinations between operating system, resolution, browsers, browser versions, etc. I set my username and access key to be fully protected as environmental variables, or you can set them in the cloud, it doesn't matter, but you need to get them and provide them here. Later, as I said, additionally, the only thing that we will change is this option here, SmartWait. For now, as I said, we're going to use hard-coded pauses, so this is why it's commented here. And we set the, based on your username and authentication key, we are setting the proper remote driver access URL to the Lambda test. That's all. So, in this particular test, we are navigating first to the demo website. Then, as we discussed, we find the element, driver find element using the CSS selector that I showed you, data product ID. Then we click it, as we discussed, and here the spinner appears, so we need to wait for 5 seconds. We do that with thread sleep. When you use thread sleep, we need to add this throws interrupted exception. Then we have this additional button appears after a few moments. So we find the element again using the CSS. We click it, and then we're on the next page. So let's return to the demo website. Now, when we click the view card, again, we want to type here, for example, happy birthday. This is our coupon. So we need to find here this text input. We can find it by, it has ID, so this is a solid locator, so we can use this ID here. We're going to clear the text, type it, and then we will click this button here. We can do that and find it using this value attribute here. So we can use CSS for this. Yeah, we can use this value star equal apply coupon, and we are going to use this value attribute. Then we are going to click it. Let's see what will happen. You will see that again the spinner appears and it will refresh our page. We click the button. Now we need to wait for it, and at the end we need, so here after clicking we'll wait again for 5 seconds, and we want to verify that here we have this message. We can find this message by this class here. So I can find it, this alert, not alert but message, by this CSS class star equal 𝐒𝐭𝐿𝐴 message. And then we are going to use the assertion library of JUnit. So let's do that. First, we are finding the coupon text field by the ID coupon code. Then we're going to clear it. This means that if there is any text, we are going to delete it. Then we're going to use the send keys method here to apply the coupon. Then we will need to find the apply coupon button, again via CSS, again using the value attribute. You can use XPath, it doesn't matter. Then we are going to click this button here. This will apply the coupon and trigger the request for applying it. In a minute I'm going to explain what this request means and how you can view it. But this means that this spinner will appear because this Ajax library, JavaScript library, it's making asynchronous code to the server, but it's not refreshing the whole page. So we need to wait here for 5 seconds. And then again, with the CSS, the proper CSS, we will find this message here. And if you're not familiar with JUnit assertions, I suggest to check the specific video about it on the Lambda Test channel. So here we have this special class assertions, and we have there this assert equals method. First, if you hover, you will see that we have the expected result and then the actual. Basically, we check that the coupon was applied successfully. The next part of our test will be to change the quantity here, update the quantity of the product. So first we're going to find this input here. As you can see, this is input number. You can find it, for example, using the title. If we find it using the title, we can type something like input square brackets at title. This is how you select a particular attribute in the HTML. Quantity, and this is our quantity. Of course, if you have more than one product, it will be totally different based on, for example, you can base the locator based on a unique title of the product or ID. But for now, this is good enough. We can find it like this. Then we can delete the number, we can type it, so clear send keys, and then we need to click this update button. To click the update button, we can again find it by the text or by the value. It's fine. But when you click it, again, this asynchronous request is sent to the server, and then we need to wait for 5 seconds. And then we're going to check this total span, that it's equal to the particular updated value. And we're going to click proceed to checkout. We can do that by CSS or the text inside, it doesn't matter. So let's continue. First, we need to find the quantity box. Here it is. Then we're going to clear it. I noticed that we need to wait a small interval here, for example, half a second before updating the number, otherwise sometimes this fails. Then we need to wait again some time. So we wait for 5 seconds after we type it, then we click the button, we find the button update cart, click the update button, wait for 5 more seconds, then we find the total order span where the price is there, and we verify the text. Then we find the proceed to checkout. As you can see, we are using the class here. This is the proceed to checkout button, and then we click it. The rest of the test is pretty straightforward and simple, since actually there are 2 variations of the test. The first one will fill all the required information here in these inputs as billing info, and the next one will log in with an existing user that was created from the first order. This is not the best practice to couple the test, but for the example we will do that now. I'm not going to inspect them one by one, because here for this part of the test, everywhere we have proper IDs here, and we can use the IDs, billing first name, last name, etc. So I will just show you the code. This is again the version where we are typing all the information. So as you can see here, let's quickly review it. first we are finding the first billing name, again by ID, we are typing my name, then last name, company, we are selecting the country, then we have the address, again we have an ID, etc, etc. We are finding IDs. When you fill the billing email, we need to wait for 5 seconds there, because a request has been triggered. And then we need to click the place order button, and this is the time where we need to wait the longest. For example, 10 seconds, because it takes a little bit more time to complete the order, to register the user, etc. A really long test, right? A lot of hard-coded pauses. It's, I don't know, maybe 40 seconds, 50 seconds, a lot of time. And imagine that we have one more test. I'm just going to copy it so that we don't waste time, because it's similar. This is similar test. The only difference here, again, the first part is similar, but then instead of typing of the billing information, we're clicking the login here link. We wait for 5 seconds until it's expanded, and then we type an existing user there so that the information is pre-filled, and we place the order. But again, we're waiting significant amount of time, maybe 40 seconds or more. Now, this is the first version, and this works most of the time. Most of the time this works. However, as I said, the drawback of this particular solution, I can show you in the lambda test. I already executed this like 20 times to make observation about the speed. So here we have the hard-coded pauses. I executed those tests a couple of times. As you can see, it takes around 56 seconds. Like 40 of them are because of the thread slips. It's a lot of time. Again, sometimes you probably don't need to wait for so long. However, if you decrease significantly half time the pauses, like once or twice or more times, if you execute the test, for example, 10 times, 3 to 4 times, probably the test will fail because the time wasn't enough. And this is a big issue because we hard-coded all of the pauses, and the vote on your website is different every time. Another way, if you watch some of other my videos on the channel, you know that many often we can, especially about the hard-coded pauses and the thread slips, this is not the suggested approach, but we can use methods like this. Let me show you. Like this one. This is using explicit wait. We use this WebDriver wait class. It provides this until method where it accepts functions or lambda expressions. Luckily for us, we have this special expected conditions class where we can say, please wait until a particular element is there, or it's clickable. It has a lot of options here. Clickable, present, we have many options here. But basically, I use this method here to upgrade our test. I removed all of the thread slips, and instead of using driver find, every time we are waiting until the element is there, and then we are performing the operation. But as you can see, this is a significant change in our code. If you watch some of my other videos or read some of my books, you know that there are more advanced patterns like decorator, adapter, proxy, and others that can be applied to hide all of this complexity and the code to be much more maintainable and beautiful, etc. However, it requires advanced coding skills, right? Even if you watch the videos, and sometimes it might be hard to refactor all of the tests. So this is maybe the fastest approach. As I said, there are a lot of asynchronous requests here. In order to handle them, let's quickly show you what I mean. If we open the network tab here, and if we check fetch commands, let's refresh. Not all, but I want only, let's say, I will return one step back. And now let's apply the coupon. Actually, let's remove it. You will notice that we have this request here, remove coupon. This is the asynchronous request that I told you about. However, we need first the server to return the response of this request before the website to show this particular message. This is why we need code like this, where in Ajax or in jQuery we can wait for all those requests to finish. But WebDriver doesn't know about that. So we need to wait for them, and in a few places, instead of long pauses, I use this wait for Ajax. This is really the optimal solution. However, most of the websites are using totally different web frameworks. One of them is using jQuery, another is using Angular, React. So in all of those cases, we use different JavaScripts to wait for that. And if we go to the Lambda test, this is the solution where, as you can see, there is a significant difference. Sometimes the execution of the test is between 30 and maybe 40, 50, sometimes seconds. As I said, sometimes it needs less time than much more. But as I said, we need to refactor the code significantly. Now, if we get the code, the same code as before with the hard-coded pauses, I just comment all of the pauses. We don't use implicit waits. We don't use this general timeout that we set here with the so-called implicit wait. We just enable here the SmartWait. Here I change it to 20 seconds. And if we execute the test, again, here we use it just in a combination with wait for Ajax, but I removed all of the other hard-coded pauses. Again, nothing from you besides just setting the timeout is needed. We are executing the test now. We can go to Lambda test. Now the test is running. And yeah, so in a second you'll see that this will pass. And if we remove this option, the SmartWait, you will notice that here, if you observe more closely, I was experimenting that I run the same test but without the SmartWait, and the test failed. And this is like, in some places just the script cannot find the element because it didn't wait enough time. And as I explained before, if you observe here the timing is slightly more than the explicit waits. However, it's something in between the hard-coded pauses and the explicit waits, which for me, and even if you play, by the way, with this timeout, the 20 seconds, if it's less, the test will be much faster, which is excellent. And so yeah, it's slightly slower than maybe the full combination of all of the design patterns and explicit waits. However, it's a little bit faster than the hard-coded pauses, but your test will be much more. This is the first time when I run it in a couple of minutes. This is why it took so long, but as you can see, on average the time is like comparable to other solutions, which is excellent. Now, if we need to wrap up, this SmartWait really can help you in multiple ways. First, this SmartWait increases the accuracy of your test results by ensuring that these actions are only executed on elements that are ready and actionable. In 95% of the cases, this will work, and I was really surprised, by the way, when I tested it. Also, your test scripts will have fewer explicit and implicit waits, which for me this is the biggest win, and thus this will make your making them easier to read and maintain. Then your test suite becomes more efficient by eliminating these unnecessary waits performing actions as soon as the elements are ready. And you have out of the box this intelligent error handling. This means that if the time specified is not met, then you will see the original Selenium error. Now, there are things to consider about the execution time. We already mentioned that. Additionally, this will work only if you run your test in the Lambda test cloud, obviously. This won't work on your local Selenium grid or locally on your browser. However, if you debug the test, you need to use the Lambda test, which probably you do. This feature significantly minimizes the risk of false positives or incorrect executions. And probably if you use reliable test automation framework already, you don't need to migrate using the feature. But in all other cases, probably for people that are just getting started with more, that don't have so advanced coding skills, this feature will be a game changer. Thank you for watching. If you have any questions, put them in the comment below, and please let me know if you try the feature and if you like it. Also, don't forget to subscribe to the channel, check the Lambda test blog, and don't forget to get your free certification about JUnit and Selenium. Check Lambda test certifications. Thank you, and see you in other videos.